a beachfront mansion in Miami, or a machine made of steel. Both cost $1 million. Which one would you choose? For farmers, the answer is obvious. Because the machine isn't an expense, it's a money printing factory. Today, you're seeing the 3 most expensive agricultural machines on Earth, and by the end, you'll understand why they're worth every penny. $1 million machine sounds insane, right? But here's what most people don't understand. These aren't toys. They're not status symbols. These are precision tools that pay for themselves in 3 seasons through efficiency, scale, and technology that didn't exist even 10 years ago. The 3 machines you're about to see represent the absolute peak of agricultural engineering. AI systems that adjust settings every second, engines borrowed from mining equipment, technology that detects individual weeds and only sprays those. We're not talking about farming the way your grandfather did it. We're talking about industrial scale food production powered by machines that cost as much as houses but generate revenue like factories. If you want to see the most expensive farm equipment on Earth, hit that subscribe button right now, because we're starting with number 3 and it's a beast. Case IH Trident 555. Oh, the shapeshifter. At number 3, we have the Case IH Trident 5550. This machine costs nearly $1 million, and it doesn't even harvest anything. So what does it do? It's the most advanced crop maintenance system ever built, and its versatility is what justifies the price. The Trident 5550 can switch from liquid fertilizer application to dry fertilizer, spreading in 42 minutes. 42 minutes. Most operations would need 2 separate machines. A liquid applicator and a dry spreader. That's $2 million investments, 2 operators, 2 maintenance schedules. The Trident does both. 1 machine, 1 operator. The hydraulic system that enables this transformation is a masterpiece of engineering. Tanks swap out, booms reconfigure, application systems change over, and you're back in the field in under an hour. But here's where it gets impressive: active suspension. The Trident can travel at 30 miles per hour across rough terrain without the cab moving. 30 miles per hour on a farm field. The suspension system isolates the cab from ground vibrations, keeping the operator comfortable and the application equipment stable. Why does this matter? Because coverage area equals revenue. The faster you can cover ground while maintaining precision, the more you can charge and the more profit you generate. But speed is useless without precision. The Trident 5550 uses intelligent nozzles with weed detection sensors. These sensors identify individual weeds using computer vision. When a weed is detected, that specific nozzle activates. If there's no weed, the nozzle stays off. This isn't blanket spraying, this is surgical precision. Here's the economic impact. Traditional spraying applies chemicals everywhere. Bare soil, crop rows, weeds, everything. The Trident only sprays where needed. On a 5,000 acre operation, this technology can save $50,000 to $80,000 per season in reduced chemical costs. Over 10 seasons, that's $500,000 to $800,000 in savings. The machine pays for itself in chemical savings alone. For custom applicators running the Trident across multiple client farms, the revenue model is even better. Charging $15 to $20 per acre for precision application, the Trident can generate $75,000 to $100,000 in revenue during a busy spring application season. 3 seasons. The machine is paid off. After that, pure profit, and the price is $1,050,000. But if you think $1 million sprayer is extreme, wait till you see the tractor at number 2. Big Bud 700, the legend returns. At number 2, we have a machine that's more myth than metal, the Big Bud 700. For decades, the original Big Bud 747 from 1977 held the title of the world's largest tractor. It became legendary, and now it's back, modern, rebuilt, better. The Big Bud 700 isn't mass-produced. This is artisan-grade heavy equipment. Each unit is essentially custom-built, using components borrowed from mining and industrial applications. This isn't a tractor you buy off a dealer lot. This is a tractor you commission. Under the hood sits a Caterpillar C18 engine producing 640 to 750 horsepower depending on configuration. 640 to 750 horses. That's more power than most semi-trucks in a tractor. But the Big Bud isn't about speed, it's about pulling force. This machine was designed to drag the heaviest tillage and seeding implements on Earth through soil conditions that would snap conventional tractors in half. Here's what separates the Big Bud from everything else. It's designed to be owner repairable. Unlike modern tractors with proprietary computer systems and dealer-locked diagnostics, the Big Bud uses standard industrial components, Caterpillar engine parts, heavy-duty driveline components from mining equipment, hydraulics built to last 40+ years. If something breaks, you don't need to call a dealer and wait days for a technician with specialized software. You fix it yourself with standard tools and readily available parts. For remote operations far from dealer support, this philosophy is invaluable. The Big Bud 700 makes sense for one type of operation, massive scale. We're talking 20,000+ acre farms in the Great Plains, Canada, Russia, Australia, places where fields stretch to the horizon. At that scale, efficiency isn't about speed. It's about pulling the widest implement possible in one pass. The Big Bud can pull 80-foot tillage equipment, 80 feet. In one pass, it covers what would take 3 or 4 conventional tractors multiple passes to accomplish. Here's the counterintuitive part. The Big Bud is actually fuel efficient at scale. Yes, it burns more fuel per hour than a smaller tractor, but it covers vastly more ground per hour. When you calculate fuel consumption per acre, the Big Bud often beats conventional setups because it's doing in one pass what others need multiple passes to achieve. $1 million tractor seems insane until you run the numbers. On a 25,000 acre operation, reducing tillage passes from 3 to 1 saves fuel costs, $100,000 plus per season time, 60 to 80 hours of operation, soil compaction damage. Operator wages for multiple tractor crews, the Big Bud pays for itself in 5 to 7 seasons through operational efficiency alone. And because it's built with 40-year components, it doesn't depreciate like conventional equipment. This is a machine you buy once and pass down to your kids. And the price is over $1 million. If this is blowing your mind, smash that like button and drop a comment. Would you rather own a Big Bud 700 or $1 million house? Because the #1 machine is even more extreme. Claas Lexion 8900, the Ferrari of combines. At number 1, we have the machine that represents the absolute peak of harvesting technology, the Claas Lexion 8900. This isn't just the most expensive production combine, it's the most advanced piece of agricultural equipment ever built. When fully configured with TerraTrack tracks and a 15-meter header, this machine costs up to $1.25 million. $1.25 million. But here's why it's worth it. The Lexion 8900 is powered by a MAN D42 engine, displacing 16.2 liters and producing 790 horsepower, 790 horses. That's more power than a Lamborghini Aventador and a Ferrari 488 combined in a combine. But raw power is just the foundation. The Lexion uses the APS Synflow walker system, the fastest grain separation system in the world. Instead of traditional straw walkers that shake grain free through vibration, the Synflow system uses a combination of rotary and walker technology to achieve separation speeds that were impossible a decade ago. This means the Lexion can process more crop per hour than any competing combine while maintaining lower grain loss. But here's where the Lexion truly separates itself. CEMOS Automatic. This is an AI system that monitors and adjusts the entire combine every single second. It tracks grain moisture, soil conditions, crop density, engine load, fuel consumption, grain loss sensors. Based on that data, it automatically adjusts ground speed, rotor speed, fan speed, sieve settings, cleaning shoe parameters. The operator doesn't touch anything. The machine optimizes itself continuously. This isn't just automation. This is artificial intelligence managing every variable to maximize efficiency and minimize loss. The Lexion 8900 has a grain tank holding 18,000 liters. That's about 510 bushels, enough to fill a semi-truck in one load. And it empties in under 100 seconds. The unload rate is so fast that grain carts struggle to keep up. The limiting factor isn't the combine, it's getting trucks to the field fast enough. The TerraTrack system uses rubber tracks instead of wheels. This spreads the 30+ ton weight of a fully loaded combine over a massive surface area, reducing ground pressure to levels comparable to a human footprint. Why does this matter? Soil compaction reduces yields for years. Every pass with heavy equipment damages soil structure, restricting root growth and water water infiltration. The TerraTrack system minimizes this damage even while processing hundreds of tons of grain per day. The Lexion 8900 can run a header up to 15 meters wide. That's almost 50 feet. With a header that wide, the machine cuts a swath through a wheat field that would have required dozens of men with scythes working in coordination. And it does it at 5 to 6 miles per hour, processing 150 plus tons of grain per hour in optimal conditions. Here's the brutal economics of modern farming. At large scale, time is everything. Weather windows are narrow, grain quality deteriorates if harvest is delayed. The Lexion 8900 allows operators to harvest 1,000 plus acres per day. A conventional combine might cover 400 to 500 acres per day. That speed advantage means harvesting at peak grain quality, higher prices, beating weather, avoiding losses, finishing before the window closes, zero crop loss. On a 10,000 acre wheat operation, the difference between harvesting in 10 days versus 20 days can mean hundreds of thousands of dollars in quality premiums and avoided weather damage. But the real value is in the technology. CEMOS Automatic reduces grain loss to under 1% in optimal conditions. Traditional combines lose 2 to 3% of grain. On a 10,000 acre operation yielding 60 bushels per acre. Total production, 600,000 bushels, 1% loss difference, 6,000 bushels. At $6 per bushel, $36,000 per season. Over a 10-year machine life, that's $360,000 in recovered grain. The technology pays for itself in reduced losses alone. They call the Lexion 8900 the Ferrari of combines for good reason. It's not just expensive, it's the peak of engineering, technology, and performance. And like a Ferrari, it depreciates slowly because demand for top-tier equipment remains high. A 5-year-old Lexion 8900 still commands $700,000 plus on the used market because farmers know what they're getting, proven performance and technology that works. And the price is $1,250,000. Quick pause. If you're loving this tech breakdown, hit that like button and make sure you're subscribed. We're wrapping up with the big question: are these machines worth it? Let's recap what we just saw. Number 3, Case IH Trident 5550, $1,050,000. Switches between liquid and dry application in 42 minutes. Smart nozzles save $50,000 to $80,000 per season in chemicals, pays for itself in 3 seasons. Number 2, Big Bud 700, over $1 million, 640 to 750 horsepower, pulling the heaviest implements on Earth. Owner repairable with 40-year component life, reduces tillage passes, saves $100,000 plus annually in fuel. Number 1, Claas Lexion 8900, $1,250,000, 790 horsepower with AI-powered CEMOS automatic processes, 150 plus tons per hour with sub 1% grain loss, recovers $36,000 per season through reduced losses. So here's the question: would you rather own a beachfront mansion or one of these machines? The mansion provides shelter and status. It appreciates slowly, maybe 3 to 4% per year. These machines generate revenue, active, productive income. The Trident makes $75,000 plus per season in custom application fees. The Big Bud saves $100,000 plus annually in operational efficiency. The Lexion 8900 can process $500,000 worth of grain per week during harvest. Modern farming isn't about farming the way it used to be. It's about capital-intensive industrial food production. The farmers who can afford these million-dollar machines thrive. They operate at scales and efficiencies that smaller operations can't match. The farmers who can't afford them either hire contractors who own these machines, or they exit the industry. There's no middle ground anymore. And here's the question nobody wants to ask: is the future of food too expensive? When farming requires million-dollar machines to be competitive, what happens to small family farms? When only operations covering 10,000 plus acres can justify these investments? What happens to agricultural diversity? The machines you just saw are engineering marvels. They're incredibly efficient. They feed billions of people, but they also represent a consolidation of agriculture into fewer, larger, wealthier hands. That's not good or bad. It just is. It's the reality of modern food production. If this changed how you think about modern farming, here's what I need. First, smash that like button. It tells YouTube this matters. Second, subscribe and hit the bell. Every week, we're breaking down the most advanced agricultural technology on Earth. The machines, the economics, the future of food. Third, drop a comment right now. If you had $1 million, would you buy one of these machines or a mansion? And which machine impressed you most? The Trident's versatility, the Big Bud's brute power, or the Lexion's AI technology? I read every single comment and I want to know what you think. And if you made it all the way here, I've got a video on screen about machines that replaced 500 workers each. You need to watch it. 3 machines, over $3 million combined. But they're not expenses, they're investments that pay for themselves. This is modern agriculture, and it's more expensive and more profitable than most people realize.